Hi guys, good afternoon everyone. So let's wait for 2 more minutes before people joins in so we can start the session. So in 2 minutes we're going to start. So I request everyone to join fast, those who are not joined in, so we can start the session on time. Okay, everyone, regarding the material, I have already shared my material with the LMS team. So they will upload on the LMS, so you guys will be able to practice them or you can view from them. So in 1 or 2 minutes, we'll start the session, guys. Good afternoon, everyone. I request all of us to join in fast, who's are not joined in. Please inform your friends, colleagues, all the respected faculty members. I request everyone to join in fast so we can start the session on time. In 1 minute, we're going to start the session. Thank you, sir, for reminding. I already shared this Google Colab notebooks and my presentation with the LMS team. So they will be soon uploading this on LMS, so you guys can have that available for your practice. All right, guys. So like one moment and we can start. I will adjust my screen and I will switch on my camera. So we can start now. I think we are already 10 minutes late. So let people join as per their convenience. All right, guys. Can you just confirm if you are perfectly able to hear me? The entire screen is visible and my camera is also switched in. So can you guys just confirm everything is good? Can we start?
Yes, Vikas, all good.
Okay. Thank you, sir. Thanks for confirmation. Abhay, sir. Desblay, sir. Thank you. Thank you, Vasui, ma'am. Thank you. So guys, let's get started. So till now, we were able to understand what is a convolution neural network, how the computer vision works in, what is the human vision, how the entire things works upon. We were able to understand all the convolution block, all the operations, what is happening in the background, how the visuals comes in into the picture. So we were able to understand perfectly what's going on. And once we are able to understand the entire operation, we have seen the mathematics behind the convolution neural network as well. So how the entire picture, when we try to pass the entire picture, how it is getting identified, right? So we were able to understand that what all the operations which are doing, what all convolution operation is happening, what is convolution block, what is padding, what is pulling. So we were able to understand, and then how entirely the images is getting bifurcated, what kind of operation happen, how why padding is important, and how line by line, how the edges appears, how the lines appears, how color, texture, pattern gets detected. And once we are able to understand that, then that is how the entire detection process happens. So guys, as a continuation, we were also started understanding the YOLO NAS, and we were able to understand that why this YOLO, why this is called as a single shot detection. What is the name YOLO suggests, right? This is what we were able to discuss, and we were able to discuss about the region proposal neural network. What was the region proposal? Why this is called as one stage detection? What happens? Okay, this entire YOLO process, this is called as one stage detection, and we were able to understand why it is called as a single stage detection, and we were able to understand the diagram. So whenever I am talking about the YOLO, let me clarify the everything. So when we are talking about the YOLO, we were able to understand that in YOLO, you only look once. You only look once. It is a direct one stage detection, because when we pass this picture first get the resizing, then it is getting to the convolution neural network. And then once we have this kind of a feature in the convolution neural network, it will have a non-maximal separation. This entire algorithm, which is able to perform this kind of a detection, this kind of an entire detection, we were able to understand this one. This detection is called as bounding boxes. So this bounding boxes and the probability, this is our main aim. This is our goal. That is what, how we are able to identify the objects. We are able to identify the objects. That is the main goal. And this process was a single shot process. And this is how the picture gets in. Then it get resized. Then we have our features. And once we have our feature, our favorite algorithm, our superhero, non-maximal separation, NMS algorithm comes into the picture. So we are going to watch, guys. Stay tuned in. Today we're going to watch YOLO. Yeah, sir. YOLO stands for you only look once. Okay. Kumar Swami, sir, it says you only look once. You only look once. So that is YOLO. So YOLO, why they call you only look once? Because they are doing the single shot detection. Single shot detection. You can see here, this human being present, the dog present, and the horse present. Within one single stage, they are able to detect everything. That is why it is called as you only look once. So it got an entire history around it, why it is calling them. And I told you guys that there is also the entire family V1 to V8. Then they have a family of Sam, cousin family. And one more cousin they have, that is YOLO NAS. YOLO NAS family. We'll speak about them. We'll speak about these things today. And we'll try to understand the coding part, like how we can implement this entire YOLO NAS algorithm and how we can customize that. That's the agenda. And then we'll start with the NLP topics. We'll understand today very, very nice project. That is a movie analysis project we're trying to understand today. So I'll show you how to take the raw Twitter data. And once we take the raw Twitter data, how we can analyze entire NLP task, like how can we clean the data, what kind of a pre-processing is required, how we convert the entire text to numbers, and then how we can apply the algorithm, how we can find out the sentiments. Okay, so we'll try to understand very, very famous example out here, very award-winning implementation. That is the Adi Purush movie analysis, sentiment analysis. We'll try to understand this project. So without wasting much time, let's try to understand what's going on here. So we'll try to watch a short episode about the YOLO. I'm going to take you to the journey of an episode. So this short episode will try to see what is this entire YOLO is all about. This is a journey. So before we begin, guys, let's try to have a quick overview. Let's try to have a quick overview. In 2015, so 2015 is the evolution of the YOLO V1 started, and then YOLO V2, then YOLO V3, V4, V5, and then entire all in recent year 2023, this YOLO V8 was introduced. So V7 and V8, these are the latest model which are introduced in last year. And then to this year also, YOLO V8 was released. This has an awesome accuracy. But what happened is, apart from this YOLO V8, they guys released one more model. Let me tell you that model. Let me rub these things and let me tell you that model. So that model name is called as SAM, segment anything. So SAM stands for segment anything. This SAM was also one of the object detection model, which was working on the some kind of a differences. We'll try to understand first, like how the entire YOLO architecture works today. So then we'll try to bifurcate, like what is the difference. This segment anything model was also went very, very viral when it has been launched this year only. So this year only, and this I told you, this is a cousin of YOLO. So they are performing also the object detection, but this Sam has their entire brothers and sisters like this one.
Vistata.
So Sam has a entire brothers and sister which we can talk about. Like segment anything model also has a two versions. One was a fast segment anything. One was a mobile segment anything. Mobile segment anything. Okay. So this mobile was a mobile version. Fast was a lighter version. This was the lighter version. So they had a less number of layers, but the detection process and the inference speed was very fast. So we'll not go into detail because it will take that time. Sam related to model two model 2 YOLO. Yes, guys, Kumar sir, yes, it is related to YOLO only, but they have a different kind of a small different architectural differences. But they are the same family only. They are same family. That's why I'm calling them a cousins of YOLO. So our main focus, guys, main interaction or our main focus is this one, YOLO NAS. So YOLO NAS, this NAS is also had some meaning, guys. Let me tell you this meaning. YOLO NAS means NAS stands for Neural Architecture Search. Okay, architecture search, neural architecture. For just please forgive me for my spelling. So this is a neural architecture search, guys. Neural architecture search. So YOLO NAS stands for Neural Architecture Search. We'll understand like why it is called as Neural Architecture Search. So first understand, we'll try to understand. And this YOLO NAS is not a single model. So YOLO NAS has three versions. One is small, one version is called as small YOLO, YOLO small, YOLO medium, YOLO NAS medium, YOLO NAS large, YOLO NAS large. It is again depends, guys. This again depend. Yes, neural architecture, sir. Correct. YOLO NAS. So, NAS architecture, we'll try to understand today. We'll try to implement this architecture today, guys. Okay, YOLO NAS architecture. Okay. YOLO NAS, sir, this has been developed this year only in the month of June 2023. Okay. Shubhodip, sir, it is released in the month of June 2023 only, YOLO NAS. So that is why we are going to look at the implementation of the YOLO NAS. This was recent model. So we'll try to understand the recent one. All right. So guys, let's try to understand. YOLO NAS variations. Yes. YOLO NAS variations, three models are there, sir. There are three models. One model, like I told you guys, one model is small, YOLO NAS small. Okay, let me rub these things. It is not coming correctly. YOLO NAS small is there, medium and large. There are three variants are there for YOLO NAS. Okay, we'll try to understand the large one, XL one. Okay, XL or large one. We'll try to understand this one. So guys, before we discuss, like I told you, these are all the topics, or these are the main objectives of the YOLO models. So let's try to understand. YOLO no, YOLO does it does image classification. YOLO model can do the image classification. YOLO model can do object and feature detection and tracking. Like let's try to understand what do you mean by object tracking. So let's imagine, guys, in your college you have this kind of a security camera. So this security camera, let's imagine it has a YOLO model behind it working for you guys. Let's imagine what will happen. So there will be no more attendance management system. There will be no more attendance management system. Let's try to discuss this one. This is a live example. You guys can understand that this is a live example. I was able to implement. I was able to check this kind of a model, and I have also experienced this model. So let me tell you guys this, what is this YOLO NAS model is all about, or sorry, not YOLO NAS. This YOLO object tracking model is all about. So let me tell you this, what is happening. Let's imagine you have a security camera. This web security camera, live feed camera is attached to the YOLO model. And what will happen? What going to happen? Try to understand the use case out here. So what is happening here actually, the moment we enter image classification, tracking, segmentation, detection. Yes, sir. All the tasks will be done, and even the key point detection also is done by YOLO. So this YOLO is a versatile model, multimodal model. So what? Let's try to understand what is object tracking it is doing. So let's imagine, sir. Those vehicle are over speed camera track the vehicle number. Yes, sir, correct. So that is how it will try able to track. It can track anything, like it has a Shubhodip sir, it has a very amazing use cases, like you can detect the number plate also. So it will be able to do a OCR reading task. and by detecting the number plate, it will able to detect the person owner, and it will it will be used for the kind of things like, imagine in your colleges or your campuses, only those cars will be allowed which are given a permission, like automatic gate opening will be done. So moving images can also be tracked. Yes, yes, sir. Moving images can also be tracked. Even live people who are doing the movements through the camera, that is getting tracked. So that is the example I'm going to discuss here. So this webcam is there. Try to understand, sir. This one. And this webcam, what will happen? The moment, let's imagine, let's take the example. Uh, let's take any example like Chandana. Let's take example of Chandana. Chandana entering the college campus at 8 a.m. 8 a.m. She's entered the college campus. The moment she enters the college campus, the entire webcam will be able to track her, and this YOLO algorithm will be working. Let's imagine what is happening, how this will help us to perform the tracking. Okay, so let me rub a few things out here, and let me show you what is going to happen and how it will replace the entire attendance management system. There will be no more manual attendance management system. This entire webcams will work as a attendance management system. Even in the corporates, they are applying this kind of things. So Chandana enters college campus at 8 a.m. and she enters through the college security gate. Let's imagine this is the college security gate, and she is appearing in the college security gate at a.m. The moment she appears, there will be entire logs will be maintained out in the background. In the databases, there will be one kind of a table, and it will have a name like Chandana. Chandana entered the college at 8 a.m. So this log will be there. And the moment she enters, let's imagine, sir, what is happening. This entire YOLO model or these web cameras will be working as a attendance management system. So what is happening? There will be no more attendance, no more biometrics attendance, no more, because people in biometrics also trying to goof off. They're trying to create a problem and they are not able to track the people entirely. So the moment 8 a.m. Chandana enters the campus, this security camera is able to detect her, and there is also a face detection model. There is also a YOLO model. So this YOLO model detected the Chandana by using the face, and this YOLO model is tracking Chandana, like when she's coming out, when she's going to the canteen, when she's doing attending the classes, at what time she's staying in the college. Okay, and when she's leaving, entire tracking is done. Like the moment you can see here, this is the live wave the live feed camera, and they are able to track the person like this one, and they are able to understand this is Chandana, this is Vikas. Okay, and they are enter the college campus at 8 a.m. And the moment let's imagine Vikas and Chandana, they enter the college, they are very jolly people. They don't go directly into the classes. They prefer to meet with their friends and colleagues, and they go to the canteens. Okay, and in canteen also there will be one more security camera. So let's imagine by 8:10 we enter the canteen, the same record will go here. 8:10 a.m. canteen. Okay, so from 8 to 8:10 I'm in canteen, and let's imagine after 8:30 a.m. we are leaving the canteen. We enjoyed our breakfast, and then we are going official work classes, break canteen, meet with the friends. Everything it will do, because I've gone through this kind of a cameras. I've gone through this kind of architecture when I was working in this company. So they had these cameras. They don't have this kind of a swapping system. No more swapping, no more biometrics. Okay. So they have a web cameras. The web cameras is tracking everywhere. Everywhere there is a web camera. And let's imagine the moment we comes in, the college canteen is here and the college building is here where the classes are taken. Here also there will be cameras. Here also there will be cameras. So they are tracking continuously. It is able to detect here. It is able to create this kind of a bounding boxes, and it is able to create that when, what time you entered the campus, what time you entered into your company premises, what time you are sitting on your computer desk. Everything is tracked. Like I was able to tell you, sir, because I worked as a manager. The track of privacy by YOLO model, not not privacy, you can say, sir, because it's a public camera, so everyone is going through that camera, not a privacy camera, you can say. But it is creating kind of a management system, attendance management system. You no more require that kind of a manual system, right? So moment I am sitting on my let me tell you, sir, what is happening. So what happened is, like the moment I enter, what happens, let's imagine my login time is 8 a.m. I enter the company at 8 a.m. But rather than going to my desk, like imagine this is my chair, and rather than going to my chair, I chit chat with the people. I enjoy my breakfast. I have a tea, coffee. Then actually by 9, I am going to my desk. Okay, the moment I am going to my desk, I'm logging. Let's imagine for 2 hours I worked in, and again I went to have a coffee with my friends, tea with my friends. I'm wondering I'm going to the another floor. Let's imagine this is my company floor. I am going to another floor. Let's imagine there is a one more story building. This building, entire building. Let's imagine this way. If this is my entire building, it has a 3 stories. So I have some work with the other department. So I am going to meet the other department. So it is continuously tracking me. Like for 2 hours, I was on desk. For 1 more hour, I went to the another campus. There I was tracked. Everywhere it is tracking, sir. Everywhere. Offices. I said, no, 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 not in the private like bio not in all the places, like in the common areas. In common areas they are putting the cameras. We are able to understand even on the production floor. Like what happens is people say that I am working 8 hours. Okay. Yeah, sir, I can understand, Kumar Swami, sir. Yes, but nowadays, you won't imagine, like in big companies like Microsoft, Google, they even they have their cameras or some kind of a privacy system installed on your computers also. So they're tracking even what kind of a code you are writing, what kind of a Windows application you are using, what kind of a apps you are using. They're tracking everything, guys. They're tracking everything. Okay. So entire things are tracked, and then let's imagine I am a manager. I am a manager. I used to manage a team of 20. And then every day in the Scrum meetings, coding counts more. Yes, correct, correct. So that's what will happen. So let's imagine every day we have a Scrum meeting. In Scrum meeting, let's imagine by 9 a.m. I have a Scrum meeting, my team, and every day's task is given to the people. And then by day end or by tomorrow 9 a.m., I ask everyone what task you guys have done. And then moment the person says that, sir, I was not able to finish this task, I would pull at that time. I will ignore one time. I will ignore two time, three time. The third time, guys, I will pull my records from this YOLO model and other model, and I will try to check actually how many hours of production these guys has done. Okay, and whether he dedicated all his time to the production or he was just wandering here and there. So that kind of a live tracking can be done, guys. That kind of a amazing use case can be done. This is good by one way. This could be bad by one way. We can discourage the moral of the people, but try to understand, like every company, they are not a free services. Here we are doing production and they are paying for us, right? So this way, guys, there is no more attendance management system. By your face, by your presence, they are able to track everything. They are able to code everything. They are able to check how many days you are present, how many days you are not present, how many hours you actually worked. Yeah, yeah, good model, but minor drawbacks will always be there. It is the way, like how the management is using, right? But it is a very powerful tool. Like you don't have to try to understand, sir, what happens in company. They have a workflow management tools. Workflow management tools, like they have a very various tools where they are doing attendance management system, like HRMS system, other system. They have a learning management system, and by this, they have a special record like system in SAP HR management system, where people are paying lakhs and lakhs of rupees per month for using this kind of a services. So imagine with a simple AI model, we are able to reduce all this cost. Okay, that is the main aim. That is the main aim why you are using this kind of object tracking. Our aim is not to track the person. Our aim is to reduce the cost of these unnecessary attendance management systems, this kind of a services, their kind of a fees we have to pay. All these kind of a things are reducing. Yes, yes. They are reducing the cost burden. That is the main aim. Sir, correct, sir. Kumar Swami, sir, correct. Your understanding is very correct. That is the main aim. There are people doing the this kind of a tracking, object tracking, and this is very, very nice object tracking they are doing. But obviously there will be certain curtains which will be put behind, so people's privacy is not getting affected. Otherwise people will start leaving the company, that's for sure. All right, sir, so I think we have understood most of the importance of this object tracking, object segmentation. Even this YOLO model, they will be able to do the post estimation. You can see here the lady is enjoying the Sunday brunch. So by looking at her facial expression, by looking at her position, we can see that she is enjoying her lunch. She is at a brunch table, and she's able to look at the what food item she's even eating. So that kind of a things, entire pose estimation, everything, action detection, all these kind of things are possible using the YOLO model. Okay, object detection segmentation. So let's try, we have spoken much that what it can do. So try to understand the internal architecture, like what it is actually exactly it is doing, and how the entire YOLO algorithm works. So very, very interesting thing. So let's watch this episode, what is going on. So guys, let me share my screen with you guys, entire screen. And I'm going to take you to one Google presentation, very awesome presentation. This has been created. Let's try to understand this one. Let me share my entire screen. So we'll go through one object, one kind of a model. one kind of a Google presentation, which is giving us entire live. We have created one presentation, guys. So which will able to tell us like how the entire model is working. So guys, quickly, if you guys can, Kumar Swami sir and other colleagues, if you can quickly give me confirmation. So you are able to see my Google presentation, YOLO. All right, thank you, sir. So guys, let's try to understand. When I spoke about you guys were asking me like how to choose the model, which model is better, right? So now you can see here, sir, that we are choosing the model and what are the parameters to choose. Okay, thank you, sir. Raja sir, thank you. So let's try to understand like how we are choosing the model and how we are trying to compare the models. So we can see here, this is the entire graph and these are the years. And we can see here that how the model is chosen and what is the two parameters we are trying to understand by using which we are trying to choose the model. So here is our famous YOLO model. And we try to compare this model with this entire RCNN family. We spoke about this. This is the two-stage detection model. Two-stage detection model. We saw that in this model, there are two architectures are working, two artificial neural networks are working parallel to each other along with the convolution block. And this is how we send our picture, and this picture get convoluted, and then it is sent to this model also, and it is sent to this artificial neural network. There is a two-tier architecture, and when whatever like bounding boxes and registration boxes it is able to find out, that information again goes in the downwards artificial neural network. Then we get our prediction y hat finally. So this kind of a process happens in the RCNN, regional proposal convolution neural network. This is what we were able to discuss. So try to understand because of this two-tier architecture, if you try to compare this with our YOLO model, which is a single stage detection model, one stage detection model, and this will try to understand later on because it is a super model which was introduced 6 months later. 6 months later, our model was introduced. 2015, first time when YOLO V1 was introduced. So at that time, if you are able to see this, there is a frame per second speed. Frame per second speed. So this YOLO, the fastest of YOLO, sorry, not fastest of the faster version of the RCNN was giving only 7 frames per second. 7 from second. This was the speed. And if you compare this speed with the YOLO, you can see 45 frames per second. 45. That's a huge difference in the processing power of the model. And then if you try to compare the accuracy, mean average precision. This is MAP, mean average precision. So this mean average precision, if you see, there is not a much difference. Even this is giving 73, this is also giving 63. Now it is a kind of a trade-off. YOLO faster than the other models. Awesome, sir. So that is why they are said that even it is giving high accuracy. This all the faster models, the RCNN families or these models, it is giving the accuracy better than YOLO, but YOLO is not giving less accuracy. 63% was a very high accuracy at that time. Okay, very high accuracy, way out of the league. But if you try to understand the speed, it is giving like 45 per second. Now let me tell you one example. Sir. So why speed matters? Let's imagine this way. In our mobile phone, we have a face detection, right? Face detection kind of a functionality. Let's imagine, guys. So you are trying to unlock your phone. Okay, I am trying to unlock my phone. Let's imagine this is the picture, very funny picture of Vikas, this funny guy out here. So it is able to capture my picture and it is able to understand whether this is a Vikas or not. Okay. Now, have you guys ever thought like it is able to do that within fraction of second? Within fraction of second. Let's imagine this is taking like 10 minutes to detect my face, then I'm doing detection, then it is able to take the process, then it is unlocking. What will happen? If it is take 10 minutes? Simply, I will put that phone on the road and I will try to drive a bike on it, right? I will go that crazy. I will throw that mobile. I'll crush them into the pieces. That crazy I will go, right? If it is try to take 10 minutes. So try to understand. That is why the speed matters. Let's imagine if you are going to any website and you are ordering something like on Amazon, just to choose the model and to click the button of buy. If you are taking 5 minutes, what will happen? You will leave that website. You will never visit. You will never forgot about doing purchase. You will never thought of visiting that website even, right? So that is why speed is very important. So look at the 7 and look at the 45, right? That is why they said, let's do a trade-off. So if it is giving high speed and even if it is giving 10 scale less accuracy, but that accuracy is awesome accuracy they have. And that is why they chose the YOLO model. So this is how, guys, this is how we have to understand like what is our my use case. So guys, then came the SSD model. SSD is called as single shot detection. Single shot detection. This was also a single shot detection model. This was a lighter version. So what happened is they have reduced the number of layers out here, and then they did some kind of a improvement, and then that's how. Nobody likes slowness and all like high Josh speed, fast. Yeah, yes, sir. Yeah, correct, sir. That's what everyone nowadays it is. That's why the fast foods are become very famous, right? So that is the entire case. Like this single shot detection model, guys, it was giving way way high accuracy and YOLO, and way high accuracy and the way high speed also. But that came 6 months later, and then YOLO. This was just the first version, YOLO V1. So YOLO V2 was also introduced, which was giving a competition to the SSD model, and then many YOLOs came in, like we discussed. Okay, so that is main the reason how you should choose the model. So without wasting time, let's try to understand how the YOLO is working. How the YOLO is working. Let's imagine what is happening in the YOLO and what is the entire architecture going out here. So for that purpose, guys, what I'm going to do is I'm going to simultaneously switch. I'm going to show you here also what is happening, and then simultaneously I'm going to open my this notebook, and in notebook also, I try to explain you the same things, that what is going on, what kind of a process is happening. So let's give me one moment. All right. So this is what is happening. Let's try to understand. Okay. So first, what we understood is about the YOLO is the moment I pass my picture, the moment I pass my picture to the YOLO, let's imagine this is the same picture. I'm trying to draw the same diagram, guys. Okay. And let's imagine here is my dog. Here is my dog. I know I am very bad at the picture. So let's imagine this is my dog picture. Okay, this is the dog, this is the bicycle, and there is a car out here. There is a tree out here. This kind of a picture I'm passing. This is my input image. Let's imagine it's a 448 into 448 into 3 image. So let me write this 448 into 448. This is the size of the image into 3 because it's a color image. There's a tree out here. There's a tree out here. There's a car out here. There's a car out here. You can understand. And there is a bicycle out here. There is a bicycle out here. Okay. This is a bicycle. This kind of a picture I am passing as an input picture, and this I am passing to my YOLO model. Okay, let's try to understand now what happens, how the entire YOLO works upon, guys. Try to understand this one. Can you explain with that application? Yes, sir. I will make you explain the code. While code, I will explain. Subbu, sir. Yes, I will explain this. But try to understand like first what is happening, how this picture get detected, what is the process going to happen. Okay, so guys, the moment I pass, okay, let's try to understand this one. The moment I pass my picture to YOLO model, what is happening? Try to understand YOLO. Okay, you can see here one box, Google Net 20 layer. So actually, people can say that Google Net concept then coding. Yes, sir. Concept will try to understand, then coding implementation will try to do. So guys, try to understand here. So what going to happen is the moment I pass my picture, there is one convolution neural network, which is a pre-trained neural network, a CNN pre-trained model. We spoke about various models. If you guys remember AlexNet, we spoke about the AlexNet, we spoke about the LeanNet, we spoke about the Google Net, we spoke about the BGG group, right? We spoke about RCNN, we spoke about the mask RCNN, we spoke about various models are there, like models who is there. So there are various models, but what YOLO is doing, they're taking a pre-trained architecture model, which is a Google Net, a Google Net model. Actually, if you go back and search like what is the Google Net model, okay, what is the Google Net model? Google Net, they have taken a 20 layer. Google Net actually has a more layers, but they have modified this. They have taken a modified version, and they have taken a 20 layer 20 layer Google Net. Okay, they have taken a 20 layer Google Net now. So imagine what is going to happen here. So moment I pass my picture, it is going. Okay, let me use the different color now. So it is going, this input picture is going to my Google Net, which is a 20 layer architecture, guys. Okay, which is a 20 layer architecture. And then what is happening, try to understand, sir, this way. So when I'm passing this kind of architecture, so this Google Net architecture is also kind of a convolution neural network, which will have a same picture, like it will have a convolution block, which will followed by the flattening layer, which will have a this kind of architecture, which is having a artificial neural network. So what only thing out here is we understood this LeNet and AlexNet, they were 6 layer, this were 8 layer. This is a 20 layer architecture, very huge architecture layer. And this is a pre-trained model, like it is able to identify already the 1,000+ category of the data. Okay, that kind of architecture I'm trying to pass out here. So that is what is happening. Okay, that is what is happening out here. The moment I pass my picture there, that picture is passed on. That picture is passed on to the Google Net. Okay, Google Net, and this Google Net has a 20 layer, and it is able to extract. It is able to extract the feature out of that. Okay, directly. We know like what kind of operation happen. But guys, what they have done is like in YOLO, obviously they are giving you some kind of space. Now they are introducing a 5 boxes out here. 5 boxes. You can see here there are 5 boxes out here. So what are these 5 boxes? Try to understand these 5 boxes. I will also draw the same 5 boxes. These 5 boxes, guys. These 5 boxes, they are provided a kind of a arrangement. Okay, kind of arrangement where you can use this kind of a 5 boxes. These 5 boxes can be used to customize the YOLO model for your own data. Okay, so that is why they are passing this kind of a 5 architecture convolution blocks: 1, 2, 3, 4, and 5. So this is what they are doing here. You can see here they are providing this kind of a blocks, and these blocks, if you can see, and then there will be a flattening layer, then there will be feed forward network, and then they will do a reshaping. And then the actual detection process will start. Okay, then the actual detection process will start. So try to understand, guys, these 5 layers and this one earlier layer, this 4 plus 1, they have given it for your training from the scratch. Like there is a already architecture, we are using Google Net, which is already trained on the 1,000 category, let's imagine. But still they are providing you this kind of a space, you can see here. So this kind of a space they are providing you where you want to customize this model for your own purpose. Okay, for your own purpose. So that is why they are giving you this kind of a space. And then, guys, once we are passing this through this layer, then actually there will be one process happening that is called as a resizing. So if you remember on the first slides, we spoke about what operation happens in the YOLO. What it is going through the CNN. Then it is doing a resizing operation, and then they apply the NMS algorithm. These 3 operations happen. Then the final object detection process starts. Okay, so that is what is happening. So we're going to understand the same thing out here. So let me rub these things which are not important again, and I'm going to explain you exactly the same way. Okay, exactly the same way that like it is happening, and we'll try to understand this process simultaneously also. What is going to happen out here? All right. Those model concept useful in detection of images with accuracy and faster detection. Yes, sir. These models are correct. Yes, sir. These models are correct. Model concept useful in detection. Correct, sir. Correct. This is the correct understanding. So, guys, let's try to understand. So, we spoke about this customization part. So, these 5 blocks are there. These 5 blocks they are given. If you want to customize the model, if you want to train the model, if you want to perform it for your own use cases. Okay. So, there is a first architecture is Google Net. Okay. First architecture is Google Net, 20 layers. There will be 20 layers. Then it has provided you 5 boxes, which is for the customization of your data. Then actual resizing will happen. Then followed by you can see here. So then you can have this kind of architecture. So you have an architecture. Let me go back to the Google presentation. Then they have a fully connected layer, and then they are doing a reshaping. Okay, there they are doing reshaping of 7 into 7 into 30, and then they will be able to find out finally the bounding boxes which are able to detect the dog, which are able to detect the bicycle, which is able to detect the car. So if I am taking only 3 classes as of now, we can take more classes. So it will detect like this path, it will be able to detect tree, and it will be able to detect the road, this kind of a small barricade out here. Everything it will be able to detect. As of now, try to understand this is my final classes, 3 classes. Okay, could be as of now. But in actual reality, I'm going to take a 20 classes. Then I'm going to explain you these classes, like how this is going to understand. Now try to understand what is happening next year. So once guys, this is the entire architecture and what is the detection process happens, and now the algorithm, how the NMS algorithm will happen. So that we're going to understand now. So before the NMS algorithm, our main hero of the picture comes into the picture. So there will be some kind of a text capture versus image detection with multiple objects. Yes, sir, guys. That can also be done here. Okay, multiple object detection will be done here. So it can do multiple object detection. It can do multiple tracking. I'm going to showcase you also practically this. I will pass this and I'll show you with the image and video data also this ULONAS. Okay. So guys, what is happening is once we have this architecture, how the detection process starts. Now we're going to understand this one now. So let's imagine this, what is going to happen here. So what is happening is resizing first. So let me draw this same diagram. Like we have seen here, the architecture is, this is how the architecture is going on. Then what is happening, try to understand out here. Okay. 4 boxes is used for the 4 classes. Yes, sir. Correct, ma'am. Madhuri, ma'am. Correct. Yes. Your understanding is correct, guys. So if I am using 4 classes, there will be 4 bounding boxes. Like by every bounding box has an individual object inside it. Okay, that is the key out here. So guys, try to understand, like focus for next 10 minutes, and you guys will be able to understand how the entire algorithm is working and how the detection process happen and what do you mean by this NMS algorithm, how this NML algorithm works upon here. So let me draw the same example, what is going on, and let me show you like what is the process happening here. So moment I pass again I'm going to take this architecture, we will be able to understand. The moment image goes in, this image goes to the Google Net 20 layer. Let me draw this again. Okay. So this is the image, this is my input image. This image has a size of 448 into 448 into 3 because it is a color image. So once I pass this image, this is going to the Google Net. Okay, this is going to the Google Net, which is also a 20-layer architecture. Google Net, which is a pre-trained convolution neural network. Pre-trained convolution neural network, which has a 20 layers. Within that, there will be 20 layers. And then they provided you separate blocks, 5 blocks, where you can provide your own data. You can customize this model for your own purpose. Okay. So this kind of a 5 layers are there. So 5 convolution blocks they are providing, and this entire thing is called as customization. So this is a space for your customizing your own data, and then they have these fully connected layers and the feed forward network flattened layer, and that is how the image getting resized here. Then you can say under. So let me draw this dog out here. I know I am very funny guy, so I'll not be able to draw the entire dog exactly, but at least I will try to reach to some kind of a arc over here. Okay, some kind of a picture I will try to draw, at least which will be able to identify an object out here. Let's imagine this is a cycle. I know I'm very bad at the picture. So let's imagine this is my dog, this is my cycle, and there is a car out here, right? There is a car out here. Let's imagine this is a car out here in the picture. Now try to understand, guys. Try to understand what is going to happen, how the entire things happen, how the NMS algorithm will work. And before LMS algorithm, this is our main hero of the episode. So we are going to watch episode number 1 of YOLO. So in episode 1, what is happening is now hero going to come. But before hero comes in, we have to create some kind of a climax, right? We have to create some kind of an environment so that it is a proper time when the hero will take the entry. Now try to understand what kind of a thing is going to happen. So you can see here what is happening the moment I am able to take the picture, the detection process starts. What is happening? The picture, whatever picture now, whatever passing through this Google Net, when we doing customization, obviously what it has created a features out here. You can see 7 by 7 into 30, 7 by 7 into 30. This is what kind of a pictures you will be able to understand here. So whatever process I am taking here, okay. So this process is having 7 by 7 into 30. So means what? So such 30 pictures, we can simply say such 30 pictures or such 30 matrices are created. Such 30 matrices created. Once it is goes through this entire process, as a result, I get a 7 by 7. I get a 7 by 7, 7 into 7. So I will explain you what is this 7, but such 7 by 7 shapes of such 30 matrices will be there. Such 30 matrices will be there. Now try to understand what kind of a process is going to happen. Once I have this 7 by 7 matrices, now I'll explain you what is this 7 by 7 matrix. Such 30 matrix will be there. This model can be applied in, yes sir, in night vision everywhere. So application of captcha code, image detection, multiple object, particular object possible to identify. Yes sir, everything you will be able to identify everything. So there is, it will do object detection, it will do image classification, it will do a segmentation, it will do a tracking also, live tracking of the person. If I see, you can see my camera here. So it will create a kind of a diagram here, the square boxes. If I move here and here, it will try to move with me. So that kind of a live tracking also will be done. So let's try to understand what is happening out here. So it can perform all the tasks. You have to customize that for that one. Okay. So so moment I getting this kind of architecture, now try to understand, guys, what do you mean by 7 by 7? So whatever picture I am getting, this is such 30 pictures will be there. Such 30 pictures I am getting as a feature out of this entire process. Then what is happening? Try to understand, guys. Very interesting thing. So try to understand how exactly we are able to detect this kind of a final boxes. Because how the exactly this picture able to understand, how this algorithm able to understand that entire in this picture, that position, it has this kind of a dog and it is able to create an entire bounding box around it, okay, or cycle or kind of a car out here. So now try to understand whatever picture I am passing over, whatever feature I am getting, such 30 pictures are there. That is why seeing the width as 30 and the size is 7 by 7 means what? So whatever picture we have, like whatever picture we have, whatever features we are getting out of this entire process, 5 customization layer, 1 layer of a Google Net, 20 layers, okay, then we are getting this kind of output feature, and then the dictation process will start. Now try to understand what is going on out here. So I'll try to draw the same thing. I'll try to draw the same thing out here, and I'll try to understand what I'm trying to do out here. So what I'm trying to do is, whatever picture I'm getting out here, I'm trying to divide this picture into the 7 by 7 grid. Okay, this is 1, 2, 3, 4, 5. Let's imagine 6, and this is my 7. Okay, so this is my 7 by 7 grid means I am whatever picture I have, then 1, 2, then 3, 4, 5, and 6. So this way I have a 7 into 7. 7 into 7 grid I am trying to create means whatever picture, whatever matrix, okay, in the background there will be matrix of numbers, in the foreground there will be picture. Access authentication box, identifying a particular object in the input image is possible. Yes, sir, yes, possible. Possible. You can like identify a particular object in the picture, okay. So that kind of a use case is also possible, Kumar, sorry, sir. Yes, it is possible to identify a particular object in the input image, okay. That is, but you have to train your model for that purpose. I'll show you like how to train these models for your own purpose, okay. So guys, what is happening is I am trying to train this model into 7 by 7 grid, okay. 7 by 7 grid means such whatever picture is there, I have divided that picture into the 49 grids. These grids, these boxes are called as grid, guys. So these boxes are called as grid. Okay. So this is one grid. This is one box. So entire picture was there. Entire image was there. Entire image I created into 7 by 7 grid. Means 49 such grids are created. 1, 2, 3, 4, 5. If I count, it is a 49 grids. Now what next? Now what next? Once I divide my picture into 49 grids, that is how the detection process will start. Now try to understand what is going to happen out here. So once I divide my entire picture, you can see the same thing. They have divided the entire picture into 49 grids. Then once I divide my picture into the 49 grids, guys, I am going to take any random one. I am going to take, let's imagine I am going to also take this random. So I will take one random grid out here. So you can see this one is a random grid. So I am going to take one random grid and then I am starting my detection process out of this 49 grids. Okay. So 7 by 7 grid I have executed, which is equal to 49. Now I have 49 boxes. That boxes is called as grids. 49 grids, and out of that I am taking one as a random. Anything you can take. Now I am taking this as a random one. Now what happened? Now what happened? Try to understand this one. So once I am going to take this random one, then what I am going to do is I am going to create one bounding box, this yellow color box around it. This is a vertical box, One vertical box I will create around this box. Okay, and before creating that, I am going to take a center of this one. I'll explain what is the center. Okay, so if I take this one grid box, what I'm going to do is I'm going to find out the center location. I'm going to take out the 5 information here out here. So once I take this random grid, I'm going to find out the center of this, and I'm going to take the center coordinates. Center coordinates will obviously x coordinate and y coordinate. This is the first information I take. Then what they said is they're going to create one bounding box, which is vertical one around this red box. So I'm going to create this kind of a box out here. One vertical box I'll create. Then once I create this, I will also going to take the information about it. So this box, what information this box can give me? So this box can give me what is the height of the box, what is the height of the box, and what is the width of the box. This kind of information I'm going to take. Then third thing what I'm going to do is, guys, once I am able to create one vertical box, I will create one more box around here, which is a horizontal box. Now try to understand why we are taking all these pains. This is a part and parcel because I want to find out to my real objects. Okay, for that purpose, I am going to start my investigation process. So this entire YOLO algorithm, it is started the investigation process. Now, if I want to investigate entire my picture where the objects are lying, I have to start cell by cell. So that is why I created 49 such cells. Out of 49 such cells, I have taken one random cell, which is the red color portion. And around that cell, I am going to create two boxes. One boxes will be a vertical yellow box. And second box, I am going to create such way, which is a horizontal box. Okay. So this way, two boxes I am creating. This is the first thing. So, sir, anyone having any questions, any doubts? please try to ping me in the chat section out here. You can see this chat section. I'll try to take the question. Prasanna Lakshmi sir, if you have any questions, so you are raising the hand, you can try to write here. XY coordinates values. Yes, it will take the XY coordinate value from here, sir. So it will take XY coordinate value as a center. Then it will try to create one horizontal box, one vertical box. Okay, one horizontal box and one vertical box is going to create this way. Okay, this one vertical, this one horizontal, such way two boxes they will create. And once we create, guys, once we create these boxes, okay, so same information I'm going to write here, height and width, height and width, okay, height and width. So such way I have an information, height and width of the horizontal box and height and width of the vertical box, V box, okay, V boxes. So I'm going to create one more box. I will take the questions, guys, simultaneously. So one box I created vertical, and same way I'm going to create one box as a horizontal box now. Okay, now many questions popping up. So two boxes, vertical and horizontal, correct, sir? And this process is done for all images. Correct, Shubhu sir, your understanding is very correct. So this is just the one example. This will happen for all across 30 matrices. Okay, so you are seeing picture, but the model is seeing the matrices, number matrices. Okay, this is what is going on. So once I am getting this kind of a two boxes, guys. So I am taken the height, I am taken height and width of these boxes. So what is the height and what is the width of these boxes? Then what is the fourth information I'm going to understand, guys? What is the first important information I'm going to take out here? Applied to all 49. Correct, sir. This is what I'm going to cover now. So this is the first thing. So we'll try to do similar thing for all the 49 boxes we're going to do. Try to understand now. Guys, first I have taken the center coordinate. Then I have taken a one vertical box. This box is vertical box and this box is a horizontal box. Okay. Then I have taken a height and width of horizontal and vertical. Then fourth information, guys, try to understand. Very, very important information. What I'm going to check out here. So then coming the very, very important things, two bounding boxes for each grid. Okay, two bounding boxes for each grid, and such thing will happen. Okay, such thing will happen. Try to understand what is going to happen out here. So then I'm taking, guys, then I'm taking the confidence scores. Now try to understand what kind of a confidence score I'm going to take out here within this. Okay, so guys, for one bounding box, this one bounding box like horizontal and one bounding box which is vertical, I'm going to take the probability scores now. Probability score. So for both the boxes, horizontal and vertical boxes, I will explain you like how it will look like. I'm going to take a probability score. Now, what kind of a probability score I have to take now? Obviously, if I am trying to find out my dog, bicycle, and car, there will be three probability scores I have to take here. So whatever boxes I have created, whatever these bounding boxes, yellow boxes, one was horizontal, one was vertical. Within two bounding boxes, what is the probability that math classes are present? What is the probability that dog is present? What is the probability that the bicycle is present? What is the probability that my car is present? If I am taking three classes, if I am taking, let's imagine in this case, I am going to take the 20 classes out here. So I am going to build this algorithm for 20 classes. So I am going to take the 20 probabilities like this one. 20 probabilities. This is the fifth information I am going to process. In one bounding box, what information I will have? I will have a center information, I will have a height and width information, and I will have a 20 probabilities. One probability will be for car. Let's imagine this way. One probability will be car. What is the probability that car is present in this bounding box? What is the probability that dog is present? Dog is present. Let's imagine in this box. Okay, there is a dog present actually. Okay, so I can say the dog probability is 0.7 max probability. Car not present, so I can say 0.1. Okay, so bicycle is not present, I can say 0.2. Okay, this kind of a, let's imagine this only three classes I am talking about. If I am taking 20 classes, there will be 20 probabilities will be present. Okay, this is what information I am extracting out of one bounding box, and there will be similar horizontal box. So for one grid box, read a grid box. Let me draw this by the red color now. This one box I am taking two boxes, and each boxes have this information of center, height, width, and 20 classes, 20 class probabilities. 20 class probabilities. Okay, this is the information I'm going to create, and such thing will happen for each and every grid. Now you can check here, each and every grid will create such kind of a boxes. So this one box will be created for one grid box. Probabilities values in between 0 to 1 for all the probable process. Yes, sir, correct. Probability will be in the 0 to 1 only. 0 to 1 only. So one grid box I have taken, and now I'm going to do this process for each and every grid boxes. How many grid boxes I have? 49. So for 49 boxes, guys, how many bounding boxes I will create in the end? Can anyone tell me? If I am creating for one bounding box, I am creating one grid box. Okay, one grid box. This red grid box is there. So one grid box, I am creating two bounding boxes, bounding box 1 and 2. You can see here, these yellow boxes. So such way, how many boxes I will end up when I try to do the similar process for all the grids out here? So 7 by 7 grid is there. Can anyone tell me how many bounding boxes I will receive in the end? Correct, sir. Correct. 98 boxes. So you can see here. Now I am moving my cursor to the next box here. So you can see here I am moving my cursor from this box to this box. Similarly for this box, this box, this box, for all the boxes till here I am going to create the two boxes each. Two boxes each. So that is why it is going to create. Correct, sir. Correct. 49 into 2. So for all two guys, it is going to create. You can see here. This is what it is showing. 98 boxes for last grid. 97 and 98. So 1 to 98. These boxes. And imagine, don't forget what is happening, what information we are storing. 7 into 7 into 2, 98 boxes are created. And out of these guys, now try to understand. Out of these 98 boxes, I have to find out which are my lucky three. Which are my lucky three who are going to give me the information for this my final object. Okay. So this is what I am going to find out. I am going to do a lucky draw. Now, who are my lucky three who are going to give me the actual object? Now it is still not the time to make the entry of the hero. Our hero is NMS algorithm. Still, we have to create some pre-processing. We have to create a pre-processing. Then our NMS algorithm will come. He will fight with the bad people and he will find out, he will help us to find out these final three boxes. Okay, this is what is going to happen. Now try to arrange these boxes. Once we have got these 98 boxes, so these 98 boxes, what it will have? Now it will have a probability for 20 classes. Let's imagine I have taken a 20 classes. So it will have a center information, it will have a height and width of the box information, and it will have a 20 probabilities out here. So I can draw these 20 probabilities here. So it will have this kind of a information out here. So which information will be stored out here? So first information will be the center point, center, then will be height, then will be width, and cross probability number 1, probability number 2, probability number 3, up to 20 probabilities. Such information is stored in one boxes. Such 98 boxes are there. And what are these probabilities? These probabilities are our final objects. So if I'm going to find out dog, I'm going to find out the car, I'm going to find out the cycle, I'm going to find out whatever information. Let's imagine I want to find out tree, I want to find out the path, I want to find out the floor. You can see the floor out here also. Entire thing I'm going to find out. That many 20 classes I'm going to find out. So that 20 probabilities are there. Now is the time to understand what is the pre-processing, what kind of a pre-processing I'm going to do out here before I call my hero. That is the NMS, non-maximal separation. Let's try to understand this one now. What kind of a things I'm going to do here. So what I have to do is I will explain you now. Now I have to start with the one class. I have to start with the one class each. Now I have a 20 classes probability. I have to start with the one class each. Now let me draw this and tell you now. So we are sufficient now. Let me draw this very quickly. So I have this kind of information with me. I have a 98 boxes out me. I'll try to draw the similar. I'll not draw exact entirely 98, but I'll try to draw the representation for them. Okay, this way, this way, this way. So we have our 98 boxes. Okay, 98 boxes are there. Now try to understand here. And in these boxes, guys, obviously we know the probabilities out here. So this will be center and then it will consist of the probabilities. Let's say 0 0.5, 0 0.2, 0 0.1, 0 0.01. What kind of a probabilities we don't know, but there will be 1 to 20 probabilities will be there for each and every box. For each and every box, this information will be there. Okay, for all the classes, whatever classes we going to have, all the classes this way. This is the 98 box, this is the 97 box, and this is box number 1, 2, and 3, and so on. So this kind of a 98 boxes. And now I have. So what I have to do is I have to start with the first class. And let's imagine the first class probability I'm going to start is a dog. I'm going to find. Now I'm going to search. I'm going to start the investigation process now. I'm going to start the investigation process that out of these 98 boxes, who is my lucky one, who is giving me the dog probability or dog kind of an entire bounding box, which will cover my entire dog. Okay, that kind of a things, that kind of an investigation process I'm starting. And our detective is an NMS algorithm. He's going to come, wait for him. So what I have to do first? I have to choose one class first. Once I have chosen a dog, then obviously what I have to do is try to understand here. So every 98 boxes will have this probability. So that probability will be about the dog. So how many probabilities I will have, guys, for dog now? In the end, how many probabilities I have? Can anyone tell me? So every box has one probability for the dog. So how many probabilities I have? Obviously, I will have a 98. Uh, we dive into challenges of the accelerating NMS and why quadratic approach result in the best in class perform. Yes, sir, we'll understand this one tiny YOLO. Yes, we'll understand. But nowadays, even tiny YOLO is now not used. So we're going to understand the neural network architecture NAS. So yes, so we'll understand this. Sir. You're yeah, Googled okay. Okay, you Googled okay. Sir, I think I thought you already used this one tiny. We dived into challenging. Yes, sir. But so what happened is like let me tell you when this first time they introduced this kind of a non-maximal separation, this went very viral actually at that time. Also explain you like what is going to happen with this one. Okay, I'll explain you also. So try to understand, sir. So I have for dog classes I have a 98 probabilities now. Okay, so let's imagine I've started with the dog class. Now I'm going to get this kind of a 98 boxes now, right? This kind of a 98 boxes I am going to have, and all these boxes will going to show me the priority for the dog. Okay, so that is what I am going to find out first. So see here, they're trying to check the dog score priority for all the boxes. Okay, then out of this box information, they will somewhere they will have a dog priority like this one, 0.5, somewhere they will have 0.3, 0.2 or 0.1 or kind of a priority they will have in each and every 98 boxes. Now, what is the first pre-processing I have to do? Okay, I will explain you. So I'll explain you, sir. I can understand, guys. You guys are very curious, and you guys are trying to find out like end of it, every part of it. It's a really nice thing. So awesome, guys. Your enthusiasm is really awesome. I appreciate the guys. You are taking efforts to understand this algorithm. Thank you for this kind of a support. So guys, try to understand what is going to happen, what kind of a pre-processing I am doing out here, right? So I'm going to do a pre-processing out here. Try to understand. So I'm taking one class has this kind of a priority, all 98 across all 98 boxes. The priority for dog will be there, and this information I have 0.5, 0.3, 0.2, 0.1, 0.0, okay, 0.000. So this kind of a priorities will be present. Obviously, first thing what I have to check is I have to keep one threshold, guys. I have to set one threshold now. I'm going to keep one kind of a threshold now. What is the threshold I have to set? Let's imagine there was set a threshold of zero point 0.2 here, 0.2. Now I'm going to check which boxes out of this all the 98 boxes, which box has the priority 0 more than 0.2. 0.2. Okay, this is what they are going to check. See here. So they are taking threshold. They are taking the threshold 0.2 and they're going to check each and every box's priority. If the value is greater than 0.2, it's okay. Otherwise, whatever boxes which has a probability value which is more than less than 0.2, let's imagine here. So there is a priority of 0.1, here is the priority 1, here is the priority of 0. So here could be priority of less than 0.15. This kind of a priorities are there. Now going to check this compare with the threshold. If it is greater than threshold, it is okay. If it's less than threshold, like this one, so I'm going to make them 0. I'm going to make them 0. This is what I'm going to do. Even let it be any kind of a priority, I'm going to make them 0. Okay. So once I make them 0, I'm going to compare this threshold, and whosoever is less than threshold, guys, I'm going to make them 0. This is what I'm going to do. Particular input image priority data value generated, which is pre-trained data in AI MLDB, which can be matched when we expect to match. Okay, this is kind of a complex, sir. I will explain you this kind of like pre-trained data, like so I will explain you this, sir. I will explain. I can understand like what you are trying to actually ask. So in particular image, like it is not happens like for every image we have a pretend something like. So it is not that simple. Like it is stores that information kind of a filter numbers. Okay, so for you guys it will not be possible to directly like match this kind of a thing. I will explain you like how we can do it. I will go slowly, but try to understand this one. That thing you guys are asking is like a very complex, sir. This kind of a stuff is did by research scientists. Okay, so so I can understand this one, your curiosity. So this stuff like your Kumar Swami sir, you're talking about, it is done by the research scientists. Like they want to understand in the background, like how the benchmarking, they call it as a benchmarking, how the benchmarking is done in the standardized data set. They have a standard data set, MS Coco data set, then they have a ImageNet data set, and then they're doing a benchmarking of the model for the mean average precision. And then on the basis of the benchmarking, they'll try to understand like how it is matching with the pre-training or not. So we'll understand that later parts, like it is very advanced topic actually. As of now, we are just trying to understand like how the algorithm works. So guys, let's try to understand. Once I am able to, so let me revise again what is actually happening. So let me revise what is actually happened. Till now, what I've done. So let's go back very quickly and try to understand what we have received as of now. So once I pass the image, guys, once I pass the image goes to the Google layer 20 layer. Then we are providing a 5 blocks out here, this kind of a 5 blocks. So these 5 blocks are for the training for the scratch. And then once this image goes through this we will receive a 30 features like this one. And whatever 30 features we are receiving, guys, out of these 30 features, I have to start my detection procedure. So before I start my detection procedure, what I'm going to do is I'm going to take one picture each. Such 30 pictures are there, and then I'm going to divide my picture into the 7 by 7 grid. That means 49 grids I have created. For each and every grid, I'm taking randomly all the grids one by one, one by one, one by one. Each grid I'm creating a two kind of a bonding boxes. One box horizontal, one box vertical. This was vertical, this is horizontal. Such two boxes I'm taking. I'm storing the information. What information? Center coordinates, height, width, and my class probabilities. Let's imagine 20 class probabilities I'm looking for. I'm looking for 20 objects out here. So I will have a 20 probabilities. Let's imagine this is what I've done. I have generated for each grid two boxes. Such way we have created a 98 boxes. Once we create 98 boxes will look like this one. And this every 98 boxes will have a information, height, width, center coordinates, and the coordinates for the probabilities. So I have to start with one class. I started detecting dog first. So I want to find out which is my final box which is having a dog information. So I'm going to start with the dog class. Then I'm setting a threshold, and this threshold I've set is a 0.2. So I'll try to compare here manually, like which is a probability which is less than 0.2. If it is less than 0.2, I'm going to put a 0 like this one. You can see here, I'm putting 0. Okay. And once I put the 0, guys, once I put a 0, then I'm going to sort my boxes. Sort my boxes. What will happen? The moment I sort my boxes, all the 0 boxes will go in the bottom. I will have a very bigger boxes on the front. So now here, if you check this order, bonding box 1 was there, 2 was there, 3 was there. They were in the number system. They were in the proper number system. When I sort them as per the probabilities, now you can see bonding box 3 has come up, 1 has come up, 98 has come up, 2, 4, and 98, they have gone into the bottom because they have a 0 probabilities. Okay. So guys, then is the entry of a hero. Now is a hero coming. So now we have reached to the climax point. Now our hero is coming. Now try to understand how the NMS algorithm works now. What NMS or non-maximal separation will do, guys. Try to understand this way. Now, once I've done this threshold part and everything, and once I've did this 0, then what I've done is I've setted these boxes, okay? Whatever these boxes are there, now I've setted these boxes, and my boxes will look like this one. So this box will be somewhere, like I will show you. So whosoever is having less than 0.2 probability, I made them 0, and then I sorted them, and this is what my sort order look like here. Okay, so what is happening? Try to understand. See here, bounding box 47 is there, bounding box 20 and 15. Let me draw the same thing, and bounding box 47. Bounding box 47 was there, 20, 15, and 20. 20 was there, 15 was there, bounding box 7 was there, and then followed by the, in the end, 8 and 98. 8, 90 was in the bottom, and there's also 1 and 4. Okay, this is also 1 and 4. So 1 and 4 went to the bottom. They have a 0 values actually. And these values, I will try to write it. Like what is there? So 0.5 is there for 47. This one having 0.3. This one having 0.2 and 0.1. Now this is what is looking like, guys. This is what my final looking like. Now my NMS is coming into the picture. My hero has taken an entry. Now my hero is a detective. He's a detective. This detective has a given a task. Out of this 98, please find me final one. Please find me final 1 or 3, which are giving me the actual object. This is what the job NMS has to do. So this means detective has to perform this. 0.2 threshold value. Correct, sir. So I'm taking 0.2, 0.2 as a threshold value. So whosoever is having a probability less than 0.2, make them 0. Make them 0. This is what I've done. And then I sorted them. Okay. Then I sorted them. Obviously, this will be not there. 0.1 will not be there. If I am taking a probability for this one, 0.2, okay. So there will be something like that. 3.2 will be there. Or could be, this will be less. Imagine this way, 0.22 is there. So someone could have a 0.32, like this kind of a probabilities will be there, okay. So yes, 0.2 will make it to 0. 0.2 it will make it to 0. Now guys, try to understand what NM is doing. Try to understand out here. So once guys, this NM is doing, so try to understand whatever boxes you have created now here, try to understand this one. So these boxes, what they're doing, okay. So you can see here bounding box 47, guys. Bounding box 47 give me the highest probability. Bounding box 47 has highest probability. Now it is giving me actual dog picture. Now there is one more, but now what is the confusion? What is the confusion? There is one more box, which is bounding box 20. Now it is also giving me dog. Okay, that is the problem. This is also giving me dog, bounding box 15, but it is not giving me entire dog. So there is one more picture, bounding box 7. It is also giving me dog, partial bicycle. Now that is the problem. This way, everyone is giving me dog. Everyone is giving me dog. Now non-maximal separation has to decide how I can overcome this one. How I can overcome this one. So how it will try to overcome? I try to understand. So what is the maximum probability box? What is the maximum probability box is there? That box will be called as bounding box max, and all other boxes, it will try to compare. What is going to do is whatever the highest probability box is there, that bounding box is called as max, and then all remaining boxes will become current. All remaining box will become current, and one by one, this max box will check with all the 98 boxes. One by one, what it is going to check? What it is going to check? It is going to check the IOU, intersection of union. So let's understand this condition now. It is going to check whether the intersection of union is greater than 0.5 or not. Let's try to understand this one, what they are trying to do. Now my NMS algorithm is coming to the picture. My NMS algorithm, now this bounding box max, this bounding box is called as B box max. So B box max is the box which has the highest probability, okay. Highest probability box will be called as bounding box max, and all the other boxes it will try to compare this way. All the other boxes all other box will become current. Now this is become going to current. So this one become current first. Let me draw this one. So the next box, immediate box will become current, and this is my max box. Now they're trying to perform condition. So B box max, whether B box max is sharing greater than the IOU. The IOU is greater than with the B box current. The IOU is greater than 0.5 or not. Now try to understand what is this IOU, guys. Try to understand this. When I'm comparing this box with this box, the current box and max box, what is IOU? Let me tell you what is IOU. IOU is intersection of union. Section of union means what is the common area. Like you can see here, both the boxes have this common area, the intersection area, that is called as IOU, intersection of union. So what is my common area? This common area with both the boxes are sharing. If my common area is greater than 50%, that is 0.5. That is what I am checking as a 0.5. If my common area is greater than 50%, then obviously I don't need the other box, green box. So this green box, try to make them zero. So this green box probability, try to make them zero. Okay, this is what it will do. And this way, then once it is compared, this B box max with the current, and this B box 20 become current, and it is trying to check whether both are sharing more than 50% common area. If yes, if they share the more than common area 50%, make them zero. Make the current box zero. So here the B box 20 was bounding box current. This was the green box. I am making them zero. Then what will happen? So by bounding box max remain the same. Now this next box become my current box. Become my current box, and then I will try to compare the same thing again. I am trying to compare whether bounding box max and again the next current box, whether they share more than 50% common area. 50%. If yes, again make them this one also zero. Now try to understand this one. What is happening? This here in this case it is yes. They are sharing more than 50%. So it will make them zero here. So it is going to make them zero. Let me show you here. So this is what they have done here, zero. You can now check here. So it is making them zero out here, right? Boundary box. Now this one, the blue box is now become current now. So now it is compare blue box with the yellow box, which is max box. Now same thing we have to cover. So whether they are sharing more than 50% area, yes or no. If yes, again make them zero. But here, in this case, this blue box and blue box and yellow box, they are not sharing the 50% common area. 50% common area. This area which I am trying to denote here is not 50%. So that is leaving them as it is. Then now trying to go to the boundary box 7. So that 7 will become max now. Okay, max now. And it will try to do the same thing with all the boxes. All the boxes will be compared one by one. And this way, guys, it will try to make them zero. Most of them will become zero. Boundary box current versus greater than 50% area means make them zero. Correct, sir? Kumar Swami, sir. Your understanding is correct. Okay. So this way, guys, what is going to happen? So this way they are going to compare each and every box as a current box with this B box max. Then guys, what will happen? This is not the end. Okay. This is not the end. What is going to happen now next is, so whatever bounding box, this 47 become max. Now the highest priority. What is the next highest priority? Next highest priority is this bounding box 15. So this bounding box 15 become a max box. This become a max box then. Then this max box now will compare with all other remaining one. Thing greater than 0.5. Yes or no? If yes, again make them zero. This process will happen. Every box will become max. Every box will become current. They will try to compare, and this way, guys, this way, end of this, what is happening? Out of 98, many boxes becoming zero. Many boxes become zero. This is how the NMS algorithm works. And once it is become zero, this is done for only one class. This will happen for all the classes, and in the end, we will have this kind of a lot of zero boxes, and actual boxes will be very few. And then is the final process. To find out which are my lucky three, because here I am trying to find out the three object. So it will try to take the class one box first, the upper box. Now, once it takes the upper box, correct, sir. Correct. This is condition. Like first make a threshold. So whatever the less than threshold, make them zero. Then try to compare NMS algorithm. NMS algorithm will compare bonding max. The highest priority will become max. And the next, then once the highest priority become max, you have to take one class first. So for one class, you have to compare all the priorities. Highest priority will become max. Then it will compare with all the boxes, whether it is greater than 5 or not, the common area, 50%. If yes, then make zero. Then the second highest become current max. Then it all other become current. This way it will happen for all the classes. Correct, sir. Okay. Then in the end, we have to take the decision whether the score is greater than zero or not. If greater than zero, then take that as a final score. Let's imagine this bounding box 3 now. So try to understand what is how the detection is happening actually. So whether this bounding box score is greater than zero, yes or no. If not, if it is zero, then skip. Otherwise, no, don't skip. Take that. If it's not a zero, then if it is a zero, then take the max box as a current box, and then try to find out this is the objective. Then once we compare this kind of a algorithm, this is decision making. So whether greater than zero or not, on the class priority is max or not for that boxes. So this one box will get assigned to one object each. This bounding box 3 will get assigned to one object. Bounding box 4, you can see here, will get assigned to one object, and bounding box 97 will one object. So you can see here directly, we can check here directly. So you can check here. So this bounding box, this 97, let me show you this. The bounding box, third box, it is responsible for the dog. And then the bounding box, this one, fourth box is responsible for this one. Okay. So this one and 97 box for responsible this object, guys. Okay. This is what the final implementation will happen. And this is how I am going to choose my lucky three boxes out of all the 98 boxes. Now, you guys were very curious, like from bounding boxes, right? From this kind of a bounding boxes and this kind of a centered coordinates, we're trying to find out what is the difference between all the YOLO models now. What is the difference? So, guys, YOLO model difference is now what is happening is this bounding boxes is very important, right? Bounding boxes and the probabilities are very important. So here we are creating only two boxes for these 49 grids. These 49 grids, we are calculating only two boxes in YOLO V1. In YOLO V2, they are created five bounding boxes. And then for YOLO V3, they are creating more grid boxes. Like out of 49, they are creating like more than 49 into 2. So that kind of architecture change. Then in the latest version, like V7, V8, what they're doing to find out these bounding boxes. What is this bounding box actually? This is some coordinate, right? Height versus width. So for predicting this height and width, to predict the height and width also, they have created a separate algorithm. One algorithm try to predict the bounding boxes, and one algorithm try to predict the class probabilities. This kind of advanced architectural changes they are doing, and this is how the YOLO V1 to YOLO V8 model are tried to combine. And you can see here in later version they have combined the faster RCNN with the YOLO model. So to give a highest performance, means they are doing a hybrid approach. Also. This kind of approach also they have done. So they have combined even the faster RCN and YOLO together, and they created a new YOLO model out of it. Okay. So that kind of advanced architecture changes these guys have done, and they were able to achieve the things. Okay, guys. So this is how the entire algorithm works. Now I know you guys are very, very curious to understand how the YOLO algorithm works in. So let me quickly share my screen and go back to my screen and show you the entire YOLO model application. How to do a code walkthrough. Let me go to the code now and try to understand. Very simple code is there, guys. Very, very simple code is there out here. So let's go to this code and try to understand. I will execute with you guys simultaneously. So you guys will be able to understand. Google Column notebook. I will also share this notebook with you guys. So guys, can you, couple of people, can you please kindly confirm that you are able to see my Google Colab YOLO NAS model. So YOLO NAS model I'll explain like in the presentation. Okay, thank you, sir. Thank you, sir, for confirmation. So guys, try to understand how to create this YOLO NAS model. Okay, thank you, sir. Bashir, sir, thank you. Kumar Swami, sir, thank you. Thanks for confirmation. Guys, quickly try to understand how to implement this YOLO NAS model now. Okay, so I told you guys like there is a change in the YOLO NAS model. Okay, this YOLO NAS model, there is a change. Let me show you this YOLO NAS model. So this information about the entire understanding of the YOLO NAS I have written. I have written what is the key features. So if you try to see this one, if we try to go through this one, I will show you this architecture also, guys. So let me show you this architecture as well. I have given a link also, guys, in the presentation. So for you guys, and so once you are able to understand, guys, like I told you, this YOLO is not a single model. So they have a YOLO NAS small, they have a YOLO NAS medium, they have a YOLO NAS large, and you can compare this model here. So yeah, they have a YOLO NAS, 6 YOLO NAS actually, but 3 are very important: small, medium, and large. You can compare mean, average, precision, and their latency. Latency means how quickly your model is going to respond to analyze, how quickly it can analyze. And if it is not able to analyze, that is called as latency, means how much time it is trying to do a inference parting. Okay, so that is called as the latency, and this is the accuracy. This is the accuracy part. Correct, guys. So these are the important model. Okay, these are important model. And I told you like this auto NAC model, automated neural architecture construction. Now what happens is, guys, this YOLO NAS model, what is going to happen is, let me tell you very small, like a very small identification. It is going to create one kind of a auto NAC pipeline. Now try to understand what is this pipeline. Since this pipeline, what happens is, they take a user trained deep neural network. User trained deep neural network. This deep neural network is called as artificial neural network. This they take in the pipeline, then they take your input data. Then there is a data set you have to decide, guys. There's a data set you have to decide. Data set means, guys, if you remember, I told you, like, there are the standard data sets are there in the market. Standard data set like MS Coco data set is there, then Pascal data set is there. Then because this YOLO model are pre-trained model. So you guys try to understand, we are not designing everything from the scratch. Okay, we are not designing everything from this model are already established. So this model has to be trained on something, right? Trained on something. So there are the standardized 5 to 6 databases are there on which these YOLO models are trained. Okay, basic YOLO model. Then these YOLO models, which are trained models, we are going to train those models. For that purpose, we have to understand on which data set this model are trained on that data set model. Like this one, MS Coco data set, Coco. Okay, MS Coco data set or Pascal data set, this kind of a data sets are there. Those models data set we have to give an input, because why? Because that models input weights, they will be taken, weightages. Dot weightages will be taken as input. Then our own custom data, then our own neural network architecture, and then they are going to access the inference system. This kind of a things will be taken into the pipeline, and by using neural network, it will create its own architecture. It will try to develop its own architecture. So it is going to undergo the redesigning phase of the pipeline, and then they will create a optimized architecture. Means what? For your model, they're going to create your own architecture, optimized architecture. Okay, it is not like for everybody it is a general architecture. If whatever artificial neural network you are going to give it, whatever input data you are giving, what is the data set you are choosing. Let's imagine in this case, we are going to choose the MS Coco data set. I will show you. And then what kind of an inference system, what kind of a things you are choosing. On the basis of that, this NAS neural architecture search will become a searching engine. It will create a kind of a pipeline, and then that pipeline will build a model like this one, the convolution model, then flattening layer, then this artificial neural network model, or maybe it will create one more architecture out here, which will able to detect the bounding boxes. One will be able to detect the probabilities. One will try to create this architecture. That kind of a specialized architecture they are creating now. Okay, so that is why that is a key feature of the YOLO NAS, and this is how the YOLO NAS works. If you want, I have given here the entire information, but it will take like 2 more session to understand only the architecture, because people, it is very new, guys. It is just recently launched in 2023 in the month of June. It has been released by the DAISY. This is the institute they have released, and this is based on the PyTorch architecture. So this PyTorch architecture is developed by the Meta or Facebook, you can say the Facebook company. Initially, they made Facebook AI research. They have published this architecture, this framework. Based on that architecture, this YOLO model work. And for them, this AC company, this organization has developed this kind of a YOLO NOS architecture, which is uses the neural network architecture to perform this kind of an entire pipeline search, and they develop the model. Okay, so they develop the model. Okay, and these are the some key features, like it is trying to do a quantization, it is trying to find out the automatic architecture design, and it is doing a hybrid quantization. Quantization means, guys, in terms of the things. Okay, in terms of the things like how it is trying to perform the computation parallel threads in the background, what kind of a calculation happening, or that kind of a structure it is trying to do, guys. Okay, so now try to understand. So since we have spoke a lot of things now, so try to understand the coding part now, how to use this YOLO NAS model. I'm going to download this YOLO NAS model. This is a pre-trained model, guys. So guys, this model how I'm going to use with a very 10 line of a code. Only within a 10 line of code I will try to execute and try to show you how to use this model. Okay, so guys, try to focus out here. And once again, guys, sorry to interrupt everyone. So can you guys please once again give me a kind of a thumbs up, a confirmation, so you are able to see my Google Colab notebook, and then I can quickly try to search these things. Okay, guys, thank you very much. So guys, try to understand, when I want to use this YOLO NAS model. Okay, so I have to install this library first, which is called as pip install super gradient. I'm going to install this library along with you guys. So once I run this, guys, once I run this super gradient, this, don't worry about the versions, don't worry about this version, guys. So once you install this one, I will try to showcase you simultaneously how to run these fields. Okay, so pip install super gradient, this is the library using which we're going to download the YOLO NAS model. Okay, so once you install here, it will try to install the requirement, it is try to collect the Hydra package, Torch, you can see PyTorch model, Onyx model, Omega model, all kind of required libraries it is going to download. And once it download, it will show you also installation and everything. Done. It will try to give you everything. It is downloaded in NumPy. Whatever calculation it requires, it will try to download all the libraries. It will try to install everything. Okay, so requirement already satisfied because I have already downloaded once. So for you guys, it will try to download everything. Okay, let it run, and within a moment it will try to finish these operations. And once it is finished and try to build the wheel, you can see it is trying to build the wheel, it is trying to import the successful importation, everything it is trying to perform. And once it is built, guys, we'll try to import the model directly then. Okay, first thing what I have to do is, first thing, attendance link is shared by my colleague, guys. So Nitin sir, my attendance link is shared by Chandana, can you please once again share the link in the chat box for everyone? Okay, guys, so you can see here, so it is able to install successfully. It has successfully installed, deprecated everything. Okay, once you do that, then next thing what I have to do is I have to install the model. Okay, I have to install the model. Okay, so what I'm going to do is I'm going to import the model first for super gradient, guys. From super gradient, I'm going to import the models, and from that model, guys, I'm going to install the large model, YOLO NAS large. So model.get, you can see here model.get YOLO NAS large, and the pre-trained, since I told you this is a pre-trained model, so I'm going to use the Coco dataset for the pre-trained model. So that datasets models weight I am going to download, and I'm going to download this model called as YOLO NAS larger model I'm going to download. And this I'm going to store in the variable, that variable name also I'm giving YOLO NAS large. Okay. So model.get is the command. I'm passing the name of the model, I'm passing the weightages, and I'm going to run this model. It will start downloading the model, guys. It will start downloading the pre-trained model for you guys. Now try to understand. Very, very simple code is there, how we can run this code. So it is try to start downloading. It will start downloading. It will show you the progress. And once we are trying to see this progress, guys, so see here it is started downloading the model. So once I am able to download my model is complete, and the thing is done, guys. That's it, job done. In 2 lines, guys, in 2 lines, I have done my entire model. YOLO NAS model is ready. Now what? My model is ready. So I have to test my model. So let's imagine this way. I'm going to open one link, guys. I'm going to open one link. Let me show you this link URL. What is picture I'm going to show you. So I'm going to copy this picture. I'm going to show you this. What is this URL is all about. And we're going to pass one picture out here. I'm going to pass one picture. You can see this picture out here. So this is the picture I'm talking about. Okay. So this is picture. Let me refresh this picture. And so you guys can see this picture out here. So guys, this picture you can see here, the students are doing party. So let's imagine, and the colleagues are there. They are in a good mood and they are doing a party. So at the home of the one of the colleague, obviously. So there are the beautiful people, girls are standing. The peoples are there out here. They're enjoying their cold drink. They have a popcorn. They have a bucket of the things, snacks. They have a TV out here. You can see there is a round table is out here. And then you can see here, there is a sofa out here, table, sofa, everything. So this kind of a multiple objects are present. TV, sofa, this kind of a system, music system is there. This kind of a multiple object URL. This URL I am going to copy and I am going to pass this guy. I am going to pass this URL now. I have copy pasted this URL over, and this URL I am going to find pass it to my YOLO NAS model large, which I have downloaded above, and predict. I am saying predict this URL now. Try to understand, guys, what is the simple command YOLO NAS large dot predict. I am passing this URL. The moment I pass this URL, guys, what should happen? So we should be able to detect all the objects which are present in the picture. Now I am going only one condition, guys. Try to understand. I am going only one condition out here. So what condition I am giving, guys? So what is the confidence score more than 25? Only show that. Only show the confidence score which are more than 25. So let me run this. Let me run. I am running in front of you guys only. This URL I have given. Now let's try to see how it able to detect. See here, guys. Within a second, within a couple of seconds, it is able to hit that URL. It is try to perform the prediction. Now you try to understand one by one what is happening. See here. The chair is detected. The chair is detected with this confidence score bounding boss chair. Now you can see bottle detected. All bottle detected. Confidence score, guys. Try to look at awesome confidence score. 0.94. 0.94. One more bottle. 0.87. The bowl of the snacks is detected 0.98. Even they have detected this cup of snacks 0.1. So you can see it is able to detect the person out here with 91% accuracy. It is able to detect this guy with 98%. You will be shocked to know it is detecting even the hair chair. It is detecting the chair. It is able to detect the hair of the person, this hair of the person, and the color of the hair of this person. And it is able to detect the TV also. See here, TV detected. TV 0.62%. It is able to detect the chair, person, TV, bottle, snacks, table, everything. Whatever object you can see here, it will be able to detect. Awesome, awesome model accuracy, right? You can see the accuracy also. Each and everything, each and every person, each and every model, each and everything, hair colors, even for the hair colors, hair are detected, guys. Chair is detected, every part is detected, okay? Every picture is detected. So you can see this awesome, awesome model, okay? So now you said, you will see, guys. So this is okay. This is okay. I passed the picture. Now, what about the video? If I pass the video, can it be able to live track the person, right? This is what you guys were curious. So let me show you one video out here first. Let me show you the student are walking into the college. That kind of a video I'll show you first. And then let me show you the original video. Then I will pass this video to my model and then see how this video is captured. Instead of video, guys, you can pass a live web camera also. That is also possible. Okay, I'll show you that code as well. I'll show that code as well, guys. So let's try to watch this video. What is this exact video is there? You can see here the people, they are walking in the college. This is the college, and there are students. They are wearing the bags. They are wearing the cell phones. They are having cell phones. They are wearing the books. They are having the backpacks, and they are approaching towards the college gate. And you can see here there is also one professor is coming out in the door, right? So students are walking. So this kind of a video I am going to pass, guys. Now let's try to understand. If I pass this kind of a video, what will happen? So let me upload that video out here. So what I will do is I will upload this video out here, and then I will pass this video to my this YOLO NAS model. So let me open this video and then okay, and it will upload the video. Then moment I upload a video, guys, what I am going to do is I am going to create a path for the video. Okay. Yeah, Kavita ma'am, attendance link is already shared. So let me share it again once again. Let me share it once again with you all. All right, guys, since this video is now uploaded, students walking. So I am going to copy the path of this video. You can go to this video. Okay, see here, there is a 3 buttons. So copy the path and same path I'm pasting here. Okay. So this is the path I'm passing input video. Then I'm saying whatever input video I given, once it is detecting, please create this output video out here. And I'm giving the name of that output video as detected video, detected.mp4. And then I'm passing it. And then I'm passing one condition. If you have a CUDA, or CPU, please pass that. So I already have a GPU. So I'm passing that information. This is my actual line. Now to YOLO NAS large to device this CUDA or CPU, then predict. Okay. I'm passing this input path. I'm passing my video and I'm saying whatever input path I pass, whatever video I pass, please save the result. Please save the result out here by name detected. So let's run this one. Let's run this one. See if it is able to detect the things. Okay, it is able to detect the things, and it will create one picture out here, video. So that video name will be detected.mp4. You can see in a couple of minutes, guys. Okay, thank you, ma'am. Thanks for confirmation. So let's see here, predicting the video. You can see the progress out here. So now it will try to create one video file, and then we'll try to check on the video and how it is doing a live tracking of the people. Okay, so we'll try to understand this one. You can pass your webcam also here. So that's not the problem. We can pass the webcam live with webcam camera, and it will try to feed or try to show you in the real time. Okay. So I am passing the video, and let's imagine once it is able to save successfully, the video will be created. I will download that video and show you again the result video now here. So let's wait for a couple of seconds. It's running, and quickly show me. Let me show you how the video will work. All right. So this video is now done. So in a moment I'll refresh. Let me refresh. See here, detected video. Okay. So detected video. Let me download the video. Let me go to downloads and open this video now. Okay. Video to picture. Your implementation of the so variables and then detection. Yes, correct. Kumar Swami sir, your understanding is correct. So let me show you this detected one now. So I am opening this detected video. Now check, this was our original video. Now check the detected video. How appear. See here, guys. On real time, it is able to detect handbag. It will detect a mobile phone also. See here, cell phone. It is detected. Okay. Pot it is detecting. It is detecting the persons. It is detecting the one more pot out here. It is detect the books. It will detect all the object. It is detecting the handbag. It is detecting the skirt of a girl. It will detect the person. It will detect everything, guys. Okay. You can run this one. You can check here. It is, you see here the mobile phone is also detected. There is glimpse of cell phone and it is able to detect. Glimpse of pot it is detecting. So this is the real time tracking. See here, real time tracking with the accuracy, guys. All right. So guys, this is how awesome this model is. Awesome model this one is, and this is able to create everything, guys. So this is how you can pass video, you can pass live webcam, you can pass image, you can pass anything. It will able to detect this. Now question comes. This is okay. Now if I want to perform a customization, now what? Try to understand this customization, guys. And 10-15 minutes. Actually, I thought we'll try to start at least NLP today, but not the problem. Tomorrow's session I will dedicate entirely for NLP. Okay. So let's understand this customization part, how to customize this for our own model, and then try to conclude this session for today. So let me hide this one. Let me go to this my YOLO NAS now model. So guys, try to understand what I'm going to do. I'm going to create this kind of a things. So I will share this code with also, guys, with you also. Don't worry, I'll try to share an entire code with you. So let's understand what I'm going to do here. So what I'm going to do is this is a very live use case, guys. Very live use case. Now try to understand how this live use case will helpful. So if you install this kind of a camera, or your college will have a campus cameras. In this campus cameras, if you try to implement this YOLO model, then immediately you guys will be able to understand. First, two things it will help you. One is automated attendance management system. Your entire savings will be there. Second thing, what will happen is, if someone is falling down, something goes wrong with some student or something is going on, some student, person, any fellow in any object, so it is falling down directly. Let's imagine someone falls sick. Yes, sir. Vijendra, sir, I will share the Google Drive link here with everyone. Immediately, I will share. Okay. Okay. I will share, sir. Don't worry. So let's imagine the use case, sir. So what is happening here? So what is happening? Let's imagine you in your college campus, because of some certain reason. So some fighting goes on, and someone start fighting, or someone falls down, or let's imagine someone get a sunstroke, or let's imagine all of the sudden due to some illness someone fall down. So once a person falls down, through the live camera, through the video, through the image, it will be able to detect, and it will try to show you this output, guys. This is our output. You can see here, fall detected with this much accuracy. And once this fall is detected, imagine the person is fall down. So immediately it will give a signal. It will give a signal. Let's imagine principal sir or the lecturers will be there on their mobile phone. They will get the notification someone has fallen down in the campus, and immediately it will also pass the same signal to the ambulance, and it will call a hospital, and it will call an ambulance. Okay, so that kind of a implementation also is possible with this YOLO. Okay, that just a small use case. So you can live this kind of a live thing you can implement in your road traffic cameras also. If someone falls down off the bike, someone meet with the accident, immediately it will capture, it will call the police, it will call the ambulance. Okay, that kind of a things will happen. So let's try to understand how to perform this kind of a customization. For customization purpose, very simple 5-liner code is there, only 5 lines, and that's it. We are doing the entire optimization, entire our customization. Let's try to understand what I'm going to do here in 5 line of code. First, I have to prepare a data. So try to understand what data I'm going to prepare out here. I have created 3 folders. One is testing, one is validation, and one is training. Now try to understand each every folder. There will be in each and every folder, there will be two folders will be there for every multi-purpose application most useful for society. Yes, sir, correct. It's very, very useful. In college campus also, you can implement this one. So please give this project to your students, okay? Free of cost software development and very live implementation. You can showcase through the companies that we have done this kind of a things. It will help you for the college campus. College campus, okay? Give this project to your students that please implement this model. This code is there. So can you integrate this with the web camera of our college? And can you send a message on the mobile phone if someone falls down, someone doing the attendance tracking system? This kind of a project, please give it to your student. And once they showcase this, they are able to build your company. There will be definitely companies who will be hiring your student, because this is a live use case. Okay, in the corporate sector, this is a real-time work. Okay, let's try to understand what is happening. So if I want to customize this YOLO NAS model, okay, so what I have to do is I have to provide a two kind of a files to this one. One, I have to provide an image picture, okay, this one image, and one I have to provide a label. Now try to understand what is this image and label. So what I'm doing, I've taken a live web camera pictures, guys. Live web camera pictures. Let me show you these pictures. Live web camera pictures. If you can see, this is a live web camera picture where when a person was running on the road, he fall down all of a sudden. Here you can see here the person has fallen down on the road. Okay, so this kind of a real-time pictures I have taken. So this is one part. Then for this picture, guys, what I have to do is, if you go to Google, there you can find the annotation tools. Annotation tools. What these tools will do, try to understand. So if I go to this Google and try to search the annotation tool, you can download that software. In that software, you have to pass this picture. Once you pass this picture, what you have to do is, there will be one option like this one. So where you have to create this kind of a bounding box around the picture. Okay, you have to draw a bounding box. So once you draw the bounding box, what will happen? It will try to take the coordinates. It will try to take the coordinates of the bounding boxes, and then it will try to store that boxes into the this kind of a files, label file. I will show you this label file, how the result look like. Okay, I can create this kind of a person's bounding box. Once I create, I will get the coordinates, coordinate y, coordinate center, position. What position I can get? I can get a height, I can get a width of these boxes. Okay, so this kind of information, these are the live picture I've taken from the web cameras. Okay, web camera pictures. So you can look at the label part here. So what kind of a label I've created? You can see here, these are the coordinates, height and width coordinate, xy coordinate. Okay, so this xy coordinate, guys, I've taken, and then I've taken a picture of these people, okay, live camera picture. So this kind of a picture I've stored, and I've created the folders. One is for training purpose, one is for the testing purpose. You can keep one more for more sure shot validation. 2 times I'm doing testing. Okay, this kind of a things I've created. I've created the folder called as fault detection. Within that, I've created this folder. Within the folder, there are 2 folders. Once you create this folder, your job is done. Now you come to this notebook, Jupyter notebook. What you have to do now? How you have to call the model? Same way like we called our LONAS model. Same way you call your LONAS model. Before that, guys, we have to check the PyTorch version. Like this is the PyTorch version. So this is a framework which is created by the Facebook AI research. So we are not using the Google, guys. We are not using the Google frameworks like TensorFlow and Keras. Now we are using different ones. So you guys can have an understanding how to use both kind of architectures. Now, guys, the moment I import the torch, you can get the name also. You can get, I can using the GPU. See, this is the name of the GPU, NVIDIA GT-Force RTX, GeForce RTX, this one. This is the GPU I am using, okay? Then how to perform this fine tuning of NAS, how to customize. I have to call one trainer, okay? So before I call my trainer, guys, I have to create 2 important folders out here. So what folder I have to create? Because one folder I have to create a kind of a checkpoint directory. What is checkpoint directory? Whatever model I'm going to download, right? YOLO NAS model, I'm going to train that model. Once I train that model, where to save that file, training files, okay? So that kind of a thing. And then second thing, I have to write the experiment name. So try to understand, I'm creating one checkpoint directory. Checkpoint directory means directory. Here I will create one directory. See here, I'll create one directory called as chkpt. This kind of a folder I will create. In this folder, my model will be saved end of the training, okay? Then I have to call one trainer variable. So try to understand what is this trainer variable. Trainer variable, I have to pass the name of the experiment. I am giving my name of the experiment is my first YOLO NAS run. My folder, this is just the name. You can give any name, whatever you wish. Okay, call this trainer, pass the name of the experiment, and pass the directory where you are going to save your model. Okay, that directory is this one, checkpoint directory. So this information I passed in here. This information, simple 2 line of information I passed in here. Then what? Then what I have to do? Once I have created this folder and given a name to my experiment, okay? So what I have to do? Now, same thing, guys. I told you there are like this kind of models are there, data sets and data loaders. So this Coco data set is there, Pascal data set is there. There is a something called a dark net, guys. So let me tell you, in our YOLO model, you imagine you called a Google Net. We use the Google Net 20 layer. This dark net is the advanced version. Dark net is advanced version, which has the 54 layers. What kind of a 54 layers? This Google layer, they have taken 30 layer Google layer, plus they have taken a 24 layer of other artificial neural network, okay, other layers, which is called as ResNet combined layer. This way they have combined the 54 layers, and that kind of a base model they are using in the background for the detection, okay. So this kind of a layers is there, that kind of a model they are using. So that is called as a dark net, dark net. So you have a Coco dataset model, you have Pascal dataset model, you have a dark net model, you have a YOLO V5 model, or you have a multiple dataset model which are available. But why I'm taking, because this is a base model, but I am working with YOLO NAS only, okay. I'm working with YOLO NAS, but that YOLO NAS should have a basic understanding which base they are taking. For that purpose, I'm choosing this one, okay. So then what? Then what I have to do? Once I am able to choose this one, simple. I am using the same library, super gradient training. From the super gradient training, I am downloading the data loader. And once I download the data loader, I am also downloading the specific data set, which data set I am using. For that data set, I am using that format trainer. Okay, so I am using data loader for super gradient, and I am using the import Coco data set. If I am using Coco model, I am using Coco model, so I am using Coco detection format trainer. Okay, this is what I am doing. Then what I have to do? So in order to run this data loader, what data loader will do? The data loader will go to this directories. It will try to take out the directories. It will try to find out the label files. It will try to find out this label file, image files. It will try to pick up the model one by one, all the pictures, and it will try to load it out here in your model. That is called a data loader. So for that purpose, you have to obviously tell the which directory you have here. So within that directory, this is my main directory, fault detection. This is what information I'm giving. Then I'm giving which one is my training directory, which one is my validation directory, and where is my label file saved. So this is my label, this is my image. Same information I'm passing here, same information. Then finally, I have to write how many classes I'm going to train my model. So here I have given only one class. If you require more classes, you can do this way. Fault detection, then you can write a comma. So I want fault detection. I also want a bend detection. If someone is also trying to stand down, that kind of a things, or someone is started crying, I have to find out. So all these kind of a things you can pass in this list, okay? And then you can train your model. But that many folders you have to create here, training folders, because you have to give that model data, okay? So that kind of a things I have created here. Then once I have created this path, guys, obviously what I have to do is I have to create this data loader. So I am calling one train data loader, validation data loader, and one testing data loader. Now try to understand what will go. The code is same, guys. Code is same for everyone. Once you understand one training data loader, everything is copy pasted. Only the paths are different. Paths are different. Try to understand what I am doing here. So I am doing train data. In the train data, I am calling my trainer. Coco detection YOLO format trainer. Within that simple same information I have to pass, which is my training directory, which is my image directory, which is my image directory, and what are my classes. What are my classes? This information I have to pass. Then I have to pass how many batch size. Means if imagine I am passing 1,000 pictures. So out of that 1,000 picture, how many picture at a time I can take the batches of the image, and number of workers is the same example, like how many workers you want to upload here for this purpose, training purpose, okay? So this kind of a things, this is for training, same for validation, same for testing purpose, guys, okay? Now what? Now we have to call these transformers, train.data.transformers. You call this transform, why we are calling transformers? Once you call the transformer, guys, so then you can call these parameters. So these parameters, like this is a small setting, don't worry about this transformer setting on. You don't worry about it, you just write as it is. I will try to understand this later on. You can plug and play with this. Okay, so now try to understand. Once I created these loaders, now you can check your data sets here. I am plotting my training data set, how my training data set look like. See here. So I have taken all possible pictures. Like if someone is playing sports, at that time he's falling down. Someone is playing football. The goalie is there. He's trying to save his goal. He's falling down. On the garden, there people are playing. In the mall, guys, someone fall down. This kind of a picture. Okay, in the mall, someone's fallen down. On the street, someone fallen down. Okay, someone has fallen down. In the garden, people are playing. On the road, guys, you can see on the road side there is a tree out here. This person has fallen down on the path, the side walking path. This kind of all set of images I've taken. Then guys, once I take this image, then I start my loader. So I'm downloading, initiating my model. For same thing, Like we tested super gradient, import the model. I am also importing my model, super gradient, import the training model, this model. Okay. What is my model? Model dot get YOLO NAS large, YOLO NAS large, number of classes. How many classes I want to train for? It is the length of this folder, length of this folder. Okay. Classes folder. So length of this folder, whatever image folders I am passing, length of that folder will be my final number of classes. And pre-trained weights. Pre-trained weight is COCO. Like I am using this COCO data set. I told you there are 5 basic data sets, 5 basic models. I am using COCO model. COCO model. Okay. So this model I am using, then it will create this kind of a large architecture, YOLO large architecture for me. So this my model is there. So once I have a model, I can start training my model. Now in training, guys, you have to provide some parameters like how many epochs, how many times you want to run your model, what kind of a loss function you want, what kind of a optimizer you want, what kind of a metrics you want, how much kind of a things you want, how many times you want to run, all these kind of things like optimizer, IDAM optimizer, stochastic gradient descent, LSM prop, or what kind of a loss function you want to use, binary cross entropy or categorical cross entropy, what kind of an optimizer you want, or how you going to calculate your accuracy. All these parameters I'm going to pass here in the training parameter. You can see here super gradient training, loss function, super gradient training, decision matrix, and super gradient training, this prediction model I'm calling, and I'm passing my training parameters out here. Training parameter, a dictionary is created, and within that dictionary I'm passing. Silent mode is like don't worry about it. Silent mode is not going to give you a notification again and again. So silent mode, that is silent best average model. So then warm up model, linear approach. So how much is the learning rate? Like how you sure your algorithm should learn? How much is the initial rate? Okay. So then what kind of optimizer Adam? What kind of initial parameters I am passing? Then how much is the initial epochs, 100 epochs? What is my max epochs? What kind of a loss function I am passing? All this kind of a parameter. You can say the threshold score also. What kind of a threshold I want? NMS algorithm stop. How many classes I want? NMS, even MS thresholds also I am setting, like NMS threshold is 0.7, then try to detect that classes, number of classes. Okay. So all this, even NMS algorithm, which is working in the background, that parameters also I can set out here for the NMS algorithm parameters. How many bounding boxes I can take, how much prediction I can take, what is my NMS threshold I'm going to check. And then I'm keeping this kind of a minimum accuracy, mean average precision, at least 50%. Try to take this to watch this model. Once I provide this information, that's it. My job is done. And start training one-liner code. Pass this code, trainer.train, take model equal to model. I have received here. I have mentioned here what kind of a model I am going to use. This model.get YOLO NAS model. This information I am passing. This model information. Then this training parameters I have calculated. These parameters I am passing. Okay. And this training parameter. Then data loaders. Which data loaders I have created. All this information I am passing to my trainer. Okay. Here to my model. I am passing this information. And I am actually passing the path where to save my best model. So here there are two options. Once you train your model, one is the best model, or you can take the latest model. So all the base model, latest model will be saved out here in the directory. And then once you are done, guys, once you are done, now you can test your model similarly tested. So call the trainer.test, take the best model. As of now, I'm taking the best model here. So this model will be saved out here in this path, and then trainer test data and pass this and try to set the thresholds. We are setting threshold 0.1 and number of classes I'm passing. So once I pass, guys, okay, guys, I'll pass the feedback link again. Okay, I'll pass. Uh, paste this link, guys, for everyone. Okay, guys. Once I done this here, so I'm passing my testing, guys. Okay, once I'm passing my testing, guys, so you can see your prediction. I'm passing the same URL. This guy. Now you can check. It is able to detect, guys. It is able to detect the person with the 72% accuracy. Okay, you can inference on video also. Like way we are done. The way you upload the give the path of the video and pass the video as a detected one, and try to run this model dot predict and pass the input path. You can see here it is able to run the model also, and it will save the file here also. All right, guys. So everyone understood how to customize your entire model. So entire thing, like how you customize for fault detection, very useful use case. So this single 5 to 10 line of a code, and you guys can customize your model, guys. All right. All right, guys. Thank you much. Can one use the YOLO pre-trained model and fine-tune it to output the labels in the different language instead of English? If you can, please explain the general steps. Yes, guys, you can do that. What you have to take the search. You have to you have to take this annotation, right? So, sir, only change will be this annotation tools, this annotation labels. So whatever labels you are passing, only labels will change, and you can pass the image because image will not have any language, right? So you can pass that and you can like perform the same thing. Okay, you can do the same process, same code. All right, guys. So I think everyone now enjoyed this entire session. You guys were able to understand like how to perform this task. Let me share, guys, immediately. Let me share this both the links with you guys. So let me hide my this one. I am passing this GitHub link, guys, for your reference. So here both the files are available, guys. Okay, both the files are available. The customized training and this one. I'm also passing this entire notebook. Okay, I'm passing this entire notebook as well, guys. So let me pass this entire notebook as well for you guys reference. Okay, YOLO NAS model. Okay, I'm passing this guys entire link to everyone for this collab link. Pre-trained model. Hope you guys now enjoyed the entire session. You were able to understand the LMS algorithm, how to perform this algorithm, how to perform customization, how to detect video, how to detect image and everything. So guys, hope you enjoyed this entire session. That's it for today. We'll wind up today and we try to start with the NLP tomorrow. I'll try to do a two project walkthrough tomorrow. One fake news detection and one movie sentiment analysis. And I'll explain you the basics also. And I'll explain the recurrent neural network guys tomorrow. Okay, recurrent neural network and basic NLP and two project I will explain tomorrow. Very, very important project, live projects for NLP. All right, guys, hope you enjoyed this entire session. I thought you found it very fruitful. So very nice object detection model walkthrough we have done today, end-to-end algorithm understanding, model implementation, customization. All right. So thank you very much, guys. So please put in comments whether you like the session, what is your thoughts about the session, and let me know, and we can wind up here then. Thank you very much, guys. Thank you very much. Thank you for cooperation and I hope you enjoyed this session.
Yeah, thank you, Vikas. Guys, I'm sharing the feedback link in the chat box. Please make sure you're attendant.
Okay, okay, okay. I'll change the, okay guys, I will give a permission to everyone whosoever is able to see. I'll share this with everyone, this notebook. Okay, so everyone can see this one. I'm sharing this.
And one more thing, I sense that whatever Vikas sent that PDF or PPTs and Google Colab, I uploaded in LMS. Please download from there.
Okay.
So there is no more questions. So we'll wind up the session for today. We'll meet you on the same time, same place tomorrow. Up to then, take care. Bye bye.